Okay, so today we're talking about regression in the Tidymodels framework. And the first thing we have to do, of course, is to load the tidyverse and the Tidymodels. And we're going to use the data frame OAW2309 for our work today. So go ahead and get all those things done, then restart the video. Okay, you're back. So here we go, library tidyverse, library tidymodels, and load OAW2309.r data. Okay. So the next step is to split the data. Put 70% of the data in training, set the strata to Tmax, and create OAW_training and OAW_test. And for this, you should just refer to the data camp course. And basically what I'm doing is following along with chapter 1 of the Tidymodels course. So go ahead, just copy and edit that code and make it work, okay? And of course, stop the video while you're working on it and then come back and we'll talk again. Okay, you're back, so let's go on. So we set a seed so that we're going to get consistent results every time. Setting seed just makes sure that you're able to debug what you're doing, because you'll get exactly the same random numbers every time. So we create the split, and then we use the training function to get the training data out of OAW_split, and we use the testing function to get the test data out of OAW_split. Okay. Now the next thing we want to do is to verify the split and make sure that you get about 70% of the data in train and about 30% in test. And you also want to examine the distributions of Tmax in the training and test data frames. They should be similar, since we specified that the strata would be Tmax. Okay? So stop the video, go ahead and do that, and then come back and restart the video again. Okay, you're back. Let's go on. So I calculated the 0.7 times n row of OAW2309, and I came up with 21052.5, and the actual number that I got in the training data set was 21050. That's very close. And then I calculated 0.3 of OAW, the number of rows in OAW times OAW of 2309, and I got 9022.5, and the actual number in the test data frame was 9025, so that's very close. Then I looked at the summary of the training $Tmax and the test $Tmax, and they're very similar up and through the third quartile, and the difference is that you have a maximum of 105 in the training data set and a maximum of 110 in the test data set. These are very, very, very rare values. You're probably there's only about 2 or 3 observations above 104 degrees. So that's okay. This looks good. Okay, so create a linear regression model and call it linear_model. So again, look at the data camp course, copy and edit the code. And then stop the video, of course, while you're doing that, and then come back and restart the video. Okay, let's look. So this is the way the author of the book did it, or the author of the Tidymodels course did it. Linear model is linear_reg, and then set engine LM, and then set mode regression. Okay, so that's copied just straight out of the Tidymodels course. There are some alternatives. In fact, I found the way he did it was kind of the longest, wound up, maybe excessively verbose way of talking about it. You could just say LM1 is linear underscore reg, mode is regression, and engine is LM. Okay? And you get exactly the same thing as you get with the linear reg model. It is also true that mode regression and engine LM are defaults. So in fact, the only thing you really need to do is to invoke linear underscore reg to create the object that you're going to work with. Okay? So what he did really spelled out a lot of detail, but it really wasn't completely necessary. Okay, the next task is to fit a model, I'll call it LM underscore fit, to predict Tmax using Tmin as the only predictor, and use the training data only. And of course, at this point you want to stop the video, do the work, then come back and restart the video again. Okay. So here we have the work. LM underscore fit is linear model, and then fit Tmax tilde Tmin, comma, data equal OAW underscore training. Okay. Now we want to look at the model. Print LM underscore fit to view model information. Also use the tidy function to look at LM underscore fit. Okay. Again, copy the code from the data camp course and do this. Of course, stop the video first and come back and restart the video. Okay. Here's LM underscore fit. It tells you that you've got coefficients. The intercept is 19.809 and the Tmin is 1.024. The tidy function applied to LM underscore fit gives you a bit more information. You get the coefficients. You also get the standard errors and the t-statistic. And what you're looking for in t-statistics, a good t-statistic is something which is an absolute value 2 or greater. And we've got that very much here. And we'd also want to get a p-value of below 0.05, which would indicate statistical significance on the basis of the t-statistic. So rounding off to the extent that they wanted to display values in this piece of software, the p-value is well below 0.05. In fact, it's reported as 0. Okay. So I want you to create Tmax underscore predictions for the test data using the predict function on LM underscore fit. And then use head and str to understand the file. Okay, so for this task, stop the video, look at the data camp course, and get the work done, then come back and restart the video again. Okay, you're back. Here's a solution. Tmax underscore predictions is predict LM underscore fit with the new data OAW underscore test. And if I look at the head of Tmax underscore predictions, what I see is a tibble, in other words, a data frame, with only one column, which is .pred. And I viewed the same thing with str, and I see I get a tibble 9,025 rows, one column, and the only variable in that tibble is .pred. Okay, so you get basically the same information looking at it with either of these two. Okay. Then I want you to use summary to compare the distributions of the actual and predicted values. Okay, so stop the video, do that, then come back, restart the video again. Okay, you're back, so let's go ahead. Here's the summary. The predictions, the minimum was 16.74 and the maximum was 86.4. And the actual values in the test data frame, let's see, the means and up through the third quartile is fairly close, but in the actual data set you had a value of 110, which I've said before, values up in this area are extremely rare, so I wouldn't expect to see you max it. But there were a lot of actual values above 86.4. So I'm a little concerned about the way this model is working at the high end. Okay. So let's see. I'm going to look at some more detail. I want you to create a data frame called tmax_results containing tmax, tmin, and .pred. So we'll have the only variable we used to make the prediction, the actual values, and the predicted values, all in a data frame tmax_results. So go ahead and do that, then restart the video after you've got it done. Okay, let's look. tmax_results is OAW_tests, and then you select only tmax and tmin, the only two things we wanted, and then bind_calls tmax_predictions, which is really the same thing as callbind, or cbind rather. Okay. So with that in hand, we're ready to evaluate the model. Use the RMSE, root mean square error, and RSQ, R squared functions. Okay, so please go ahead and do that. Then after you're done, restart the video. You're back, so let's take a peek. So to use the RMSE function, we start with tmax_results, and then the RMSE of tmax, .pred. Now this, of course, is the same thing as calling RMSE with a first argument of tmax_results. That's, of course, what the pipe does. And we see we have an RMSE of 9.89. So that means that your typical error has, roughly speaking, an absolute value of 9.89. And that's the thing I'm going to focus on as we improve a little bit on this model. And here's the same thing with the R squared. The R squared tells you that you've got approximately 48% of the variance explained by the model. Okay, create an R squared plot of model performance. So follow the code in the data camp course to do this. Then come back and restart the video after you're done. Okay, let's take a look. So here's the code to do it. And there's not much to say about this code. The AB line, GM_AB line, basically fits inserts the line along the 45-degree angle from the origin, which is an intercept of 0 and a slope of 1. And then coord_ops predict lines up the axes so that they both show the same values. And again, I noticed that this looks pretty good right in here, where you're having an even dispersion above and below. But out here I noticed that for high values of actual Tmax, I'm not really getting up to the level where the observed values are. Well, the predicteds are below the actuals, which we saw also in an earlier case. Okay, so I want to recreate the model using last_fit and print the values of r squared and root mean square error, and prefix the fit and df_objects with base underscore. Okay, so go ahead and do that following the code in the Tidymodels course. Stop the video, get that done, then come back and restart the video. Okay. So here we've used last_fit to create base_fit. And we've got the root mean square error, same thing we had before. We're just getting in a slightly different way. And the r square that we had before, just in a slightly different way. But this is much more concise. It's not so spread out over many different steps. It's just one quick step. I want to talk about an alternative model, and I want you to copy the code from the previous chunkin and create a model which is MO_, where the only predictor is the factor MO, and then compare the performance matrix. Actually, the only performance metric I'm really concerned with is root mean square error. Okay, so stop the video, get that done, and come back and restart the video. Let's take a look. So MO_fit is linear model, and then last_fit, Tmax tilde MO. So that's the only thing that's here is just MO. And the split, of course, is OAW_split. Then we get MO_DF by taking that fit result and applying the collect_predictions function. And then we get the root mean square error, which is 7.2. Now you recall the root mean square error when we just used tmin as the predictor was 9.89. So this is interesting because it tells you that just by considering nothing other than the mean value of Tmax for a month, you do better than considering the Tmin value for a specific day by quite a lot. So you went from 9.89 down to 7.2. And the R-square, which I'm not following as closely, improved from 48% to about 73%. Okay. So the following procedure gives a table with the coefficients of the model. You can't directly tidy a fit object. So I take mo_fit and I extract workflow, and then I apply the tidy function. Now let's look at this. Because you're only using the intercept in the regression model, what this really amounts to is just getting the average value of Tmax for every month. And look at the coefficients. You have an intercept, and then you have months 2 through 12. The intercept is effectively the average value for month 1. And what this says is that for month 2, you're greater than month 1 by 4.02. So it would take you up to about 48.92 by putting these two together. And for month 3, you would add the 8.6 to the 44.9. And for a month 7, you would add 32.5 to the 44.9. Okay? And if you look at the t-statistics, you remember that I said for a coefficient to be significant, you want to see a t-statistic of absolute value greater than 2, which is the same thing as a p-value below 0.05. And all of these p-values are below 0.05 except for this one, which is 8.59 e minus 1, which is essentially 0.86, which says that there's really no significant difference between month 12 and the base, which is month 1, the one omitted value from the month series. Okay? One more model. I want you to run a model with both MO and Tmin and compare the RMSE value with the previous model. So go ahead and do that. And of course, you'll have to stop the video while you do your work. Then come back, restart the video. We'll look at the very last slide. Okay, let's take a peek. Here we have Tmax tilde MO plus Tmin. So we're using both of the variables that we've considered before. And that manages to drop our root mean square error from 7.2 to 6.95 and gives you a minor increase in the R-square value. And again, if you want to compare things, the slope is always 0.298, but the y-intercept varies from month to month. For month 1, which is the omitted category, you have an intercept of 35.4. But for month 2, you would have an intercept of 35.4 plus 3.77, whatever that turns out to be. And for month 12, it says you actually go down a little bit, negative 0.27. But notice that your t-statistic is, for that particular month is well below 2, and also the p-value 0.25 is well above 0.05. So it says that, again, that there's really no difference between December and January. Okay, so that concludes everything I'd planned to do with Tidymodels Regression. And again, these notes are available in Moodle.